You've eaten honey your whole life, on toast, in tea, straight from the jar at midnight, and you've probably never once felt guilty about it. But here's the thing, the bee that made your specific jar almost certainly never tasted a single drop of it. Why do bees produce way more honey than a hive could ever eat in a season? What's actually happening inside a bee's body when it turns flower juice into something that lasts 3,000 years? Why does a worker bee live only 6 weeks and spend most of that time making food it will never touch? And how did humans figure out they could steal from a hive without destroying it? The answers involve a triple chemical lock, a cave painting 8,000 years old, and one of the strangest survival systems any creature has ever built. You open a jar of honey, thick, golden, faintly floral. You spread it on toast without a second thought. You've done this hundreds of times and never asked the obvious question, why did a bee make this? Plain answer, honey is a concentrated sugar solution that a colony of bees manufactures from flower nectar, stored as their primary long-term food supply to survive winter when no flowers exist and foraging is impossible. Key word there is colony, not a bee, a colony. The individual bee that collected that nectar is almost certainly already dead. The misconception almost everyone carries is that bees make honey because that's just what bees do. Instinct, identity, it's their thing. This idea formed because we only ever see the finished product sitting in a jar on a supermarket shelf, completely cut off from why it exists. But raw flower nectar is about 80% water. Left as is, it would ferment and rot within days, completely useless as a winter food supply. Therefore, bees don't collect nectar to store it. They collect it to transform it into something that cannot rot, a food that outlasts the bee, the hive generation, and in extreme cases, the civilization that found it. Honey discovered in Egyptian tombs has been dated to roughly 3,000 years old and was reportedly still edible when archaeologists opened it. Your jam lasts 3 weeks in the fridge. That gap is not an accident, it is the entire point. So how does a bee turn watery flower juice into something that survives millennia? A forager bee visits up to 1,500 flowers in a single trip, storing nectar in a special second stomach called the honey stomach, completely separate from its regular digestive stomach, existing only to carry and begin processing nectar. One forager carries about 40 milligrams of nectar per trip. A full 500-gram jar requires roughly 2 million flower visits. During the flight home, enzymes in that honey stomach begin breaking complex sugars into simpler ones, glucose and fructose, which are more stable and harder for bacteria to use as food. The bee is already chemically converting the nectar before it even lands, but it gets weirder inside the hive. Back at the hive, the forager passes the nectar to a house bee through regurgitation. The liquid is passed back and forth between bees up to 20 times, each pass adding more enzymes and evaporating more water. This is the part nobody pictures when they spread honey on toast. It has passed through the mouths of roughly 20 bees before it reaches a comb cell. For house bees then spread the partially processed nectar across open honeycomb cells in thin layers and fan it with their wings, running a tiny evaporation operation inside the hive, kept at around 35 degrees Celsius, which is about the same temperature as a warm summer day. Water content drops from about 80% in raw nectar all the way down to below 20%. At that point, sugar concentration is so high that almost no bacteria or mold can survive. Once the water level is right, bees seal each cell with a beeswax cap, airtight, chemically stable, preserved indefinitely. But here's where it gets crazy. 3 overlapping factors make honey essentially immortal. First, the extremely low water content means bacteria can't absorb enough moisture to survive. Second, the extremely high sugar concentration pulls water out of any bacterial cell that tries to grow, killing it by dehydration, like throwing salt on a slug. Third, bees add an enzyme called glucose oxidase that produces small amounts of hydrogen peroxide, an active bacteria killer. Think of it as a triple lock on a vault. The first lock starves bacteria of water. The second dehydrates any that get through. The third actively kills the survivors. Honey doesn't just resist bacteria, it hunts them. And that's why a sealed jar can sit in a tomb for 3,000 years and still be fine. Now here's the comparison that changes how you see the whole thing. Honeybees versus bumblebees. A honeybee colony contains 20,000 to 80,000 bees and survives winter as an entire active colony. Therefore, it needs massive food reserves, ran up to 60 pounds of stored honey just to get through cold months alive. That's the weight of a large dog in honey just to survive one winter. A bumblebee colony, by contrast, has only 50 to 400 bees, and the queen hibernates alone underground while the rest of the colony dies each autumn. Therefore, bumblebees never need to stockpile significant reserves at all. They produce a honey-like substance in tiny amounts, enough to feed larvae for a few days, but nothing resembling the golden surplus in commercial jars. Bumblebees technically make honey, about 1 teaspoon worth total ever for the whole colony. The jar in your pantry exists because honeybees face a winter survival problem that bumblebees solved by dying instead. The oldest evidence of humans collecting honey is a cave painting in Valencia, Spain. He estimated at around 8,000 years old, showing a figure climbing a rope ladder into a wild bee nest in a rock face while bees swarm around them. These were not beekeepers, these were honey hunters, climbing cliffs, absorbing stings, reaching barehanded into wild hives for a food so energy-dense and rare that the pain was worth it every single time. For most of human history, concentrated sweetness was genuinely scarce. Fruit was seasonal. Sugarcane didn't exist in most of the world. Honey was one of the only consistently available concentrated sweet substances anywhere, and it never went bad, which made it almost miraculous by ancient standards. Ancient Egyptians kept domesticated bees in clay cylinder hives along the Nile as early as 2400 BCE, the first recorded managed beekeeping anywhere. That 3,000-year-old sealed jar found in a pharaoh's tomb was reportedly still edible. The human-bee relationship wasn't invented by commerce, it was built on genuine scarcity and on exploiting a surplus the bees made for winter and never got to use themselves. This is the part everyone misses. Every property bee's engineered into honey to survive winter. Antimicrobial, shelf-stable, energy-dense, moisture-pulling makes it useful for a surprising number of completely different problems. Cough medicine and throat lozenges use honey because it coats and soothes throat tissue, and multiple studies suggest it performs comparably to some over-the-counter cough suppressants for mild symptoms. Medical-grade Manuka honey is used clinically on burns and chronic wounds. The hydrogen peroxide it produces, combined with its low water content, creates an environment bacteria simply cannot survive in. Barbecue glazes and marinades use honey because its sugars caramelize at lower temperatures than regular table sugar, and its moisture-pulling nature keeps meat surfaces from drying out during cooking. It's doing chemistry, not just adding sweetness. Commercial bread and baked goods use honey specifically to extend shelf life by holding moisture in the product and slowing staling. Bakeries use it as a functional ingredient, not a flavor choice. Energy gels and sports nutrition products use honey because glucose and fructose are rapidly absorbed simple sugars. Ancient Greek Olympic athletes consumed honey before competition for exactly this reason. Mead, the world's oldest known alcoholic drink, predating wine and beer in many cultures, is simply honey fermented with water. Honey naturally carries wild yeast on its surface, making fermentation almost inevitable if you add water and wait. Skincare products, lip balms, and face masks use the same moisture-pulling chemistry that makes honey useful on wounds to draw hydration towards skin. And the tea or coffee you sweetened this morning with honey instead of sugar. You weren't just changing the sweetness, you were adding flavor compounds from specific flowers that granulated sugar could never carry. Clover honey and Manuka honey are chemically different substances, not just differently labeled versions of the same thing. Here's the honest part, though. The surplus humans have been exploiting for 8,000 years is under real pressure now. Colony collapse disorder, where worker bees abandon a hive suddenly, leaving the queen and food stores behind, has caused major hive losses since the mid-2000s. The causes are still debated but likely involve pesticide exposure, habitat loss, parasites like the varroa mite, and reduced flower variety in heavily farmed landscapes. You might think this is a separate environmental concern, but honeybees pollinate roughly one-third of the food crops humans eat. Not honey crops, but almonds, blueberries, avocados, cucumbers, and dozens of other fruits and vegetables that need insect pollination to produce food at all. The honey problem and the food supply problem are the same problem running through the same insect. Bees make honey to survive winter, not for toast, not for tea, not for you. The worker bee that made your jar lived 6 weeks, visited flowers by the millions, passed nectar through 20 mouths, fanned it dry for days, and died before the cold even arrived. You've been eating a survival system this whole time. Turns out, it's one of the best engineered foods that has ever existed.